I wonder if I can just sit here and let you take it in. See if you can figure out what this is about. I could say you could put a plus there to make what's on top reflect this chemical equation on the bottom. Sodium ion. Let's see if that makes sense. Remember sodium, 11 protons. Here it has 10 electrons, so it has a plus 1 charge. We just don't write the 1. See my plus there? Chlorine, the chlorine atom, has 17 protons. This has, wait a minute, something's wrong here. This should be an 8, shouldn't it? 8, that would be 10. This has 18 electrons. Now that I've corrected my typo, I have a true chloride ion, 10, 18 electrons. And again, there's a negative 1 there. We just don't write the 1. We say that it's understood. And what you see here is how oppositely charged ions, a positively charged and a negatively charged ion, can come together in a solution to form a compound. Now, this compound is an ionic compound, and what this formula really means is that for every sodium ion, I'm going to have 1 chloride ion. Again, we just don't write the 1s down here in the formula. And what actually happens is that when you move the water away from these ions, that should be a negative, you get a crystal. And can you draw 3-dimensional crystals? I doubt that I can. But anyway, you get a 3-dimensional crystal of salt. And that salt, and this, by the way, is what we call table salt. That salt is really, really soluble in water. For reasons we'll talk about later, water molecules will interact with these positively charged ions and their negatively charged counterparts, and they'll pull the salt crystal apart. And we say that is dissociation. We'll talk about that in physiology as well as in your review, where the sodium ions that were part of a crystal of salt, just when you sprinkle salt on your food, will come apart from the chloride ions, and those will be mixed in water. That's the nature of an ionic compound. So this interaction here, coming together to form a sodium chloride crystal, that is an ionic bond. Let's take just a moment or two to talk about different ionic compounds. Calcium happens to be one of those atoms that's in the second column, the second group. So unlike sodium, which will only lose 1 electron, calcium will lose 2, and so it forms a positive 2 charge. Now, what I want to just show you so that you can understand a little bit about how to read chemical equations is how we write the formula for the ionic compound that will be formed when calcium plus 2 and chloride negative, I'm going to write the 1, negative 1 come together. The way to draw these is to take the number that's on the positive ion and write it as a subscript after the negative ion, and take the number that's on the negative ion and write that as a subscript for the positive ion. And let me show you what this does. What it means is that I have in a crystal of calcium chloride, I have 1 calcium ion, and that's plus 2, right? That's its charge. And I have 2 chloride ions. It's a ratio, really, that says that for every 1 calcium, I have 2 chloride. And again, I'm going to write my negative 1 here. And so what we're doing is, watch, I have 1 times a positive 2 plus 2 times a negative 1. So I have a positive 2 and a minus a negative 2 that come together and give me a net charge of 0 on this formula. So again, we don't generally write the number 1. So this compound, CaCl2, is an ionic compound called calcium chloride. It's not an especially soluble one, but if I put it in water and work at it a little bit, I can get calcium to come apart. There's only one of them, but that ion has a positive 2 charge. And chloride, there are 2 of those, 2 Cl's, and each of them has a negative 1 charge. Do you see what I did? So what we illustrated here is the formation of ionic bonds. And again, it would be a crystal. This formula tells me that the ratio of calcium to chloride is 1 to 2 in that crystal. They come together to form the ionic compound. You put them in water and stir them up nicely, and they come apart to form ions in solution. I'm going to write that down. Ions in solution. That's if I put them into water. You know what ions in solution are called? They're called electrolytes.